Hello, I am going to attempt the PCNSA 1 week from yesterday. I'm going to try and take it on Monday at 10 o'clock. It is currently Tuesday at 3 p.m. the prior week. So I wanted to kind of go over some of the things. My thought is, I watch all these smart guys like Jeremy Shara, Dana Knox. They kind of go over these different topics, and their concept, I believe, is if you can teach it to somebody else, you probably know it fairly fluently. I also have a problem where I'll read stuff, I'll watch videos on it, it just won't stick. So I'm going to try this method of learning here and see what I can come up with. So, like I said, I'm going to try and take the PCNSA a week from yesterday. I've gone through probably the first third of this. The first section up here, where they kind of talk about the different essentially services Palo offers. I need to get a better understanding of that. I've read through it. I've watched videos on it. I don't know how well that's going to be covered on the test, but it's something I need to go over regardless and freshen up on. So I guess I'll start with this right here, exam domain 1.2, and what they're trying to explain here. And I'm going to try my hardest not to read this out to whoever may be watching this. This is just kind of to, again, ingrain this information in my brain. So, you've got your different next-gen firewalls. I am normally a Cisco guy. I've got a CCNP and route switch, and I've been managing ASAs for some time now, so I'm pretty familiar with that. I haven't done a lot with firepower, but I know that the firepower is essentially just a bolt-on module to the ASA, or at least that's how it is at this point in time. I know they sell, firepower appliances now that can run ASA code. So the Palo kind of takes a different approach and everything. It uses the SP3 engine, and I think the concept here is inspect it once and inspect it in parallel. So instead of sending data to different traffic engines, you're going to analyze the packets all through one flow. So that's kind of where the I guess you could say that's where the performance of the Palo really shines. Is inspect it once, don't send it to multiple different different places to analyze the data. So here you can kind of see where they're showing it on the wire, layer 2, layer 3, HA, all that fun stuff. Once you start inspecting it, it's going to look at the user ID first. You may try to do the zero trust type thing where you're proving who you are, maybe with multi-factor, maybe with captive portal. I don't know where HIP checks really come into this. I would think this would be in the same area, but it's going to do that. Then it's going to look at the app via app ID. It's going to try to determine, what application is this? Is this SSL? If it is SSL, can I decrypt it? Is it YouTube? Is it Google Drive? Et cetera, et cetera. And then once you get up beyond that, say you permit Dropbox, and you only want to permit a certain URL for Dropbox. You can just permit that URL, match the application that it's hitting on, and do that. It's also where you're going to get your antivirus, anti-spyware, wildfire analysis to happen. So pretty cool stuff. You can do a lot with this. It's a lot more impressive, I would say, from a feature standpoint than what a normal ASA can do. But that being said, there's so many ASAs out there, it's going to be a long time till those are all gone and phased out. So they also then go into different planes. So there is the management plane and the data plane. Management plane is going to be where all of your logging, reporting, your config is going to happen. So you can kind of think of it as, I don't think they might be two separate processors, or they might be just course allocated to that function. I'm not really sure the nitty gritty in there, but basically you have one plane that's just for the reporting, logging, and firewall configuration. That way, say you run a giant report and it's just slamming your CPU, it doesn't have any impact to the business, right? It doesn't have an impact on the data plane CPU. You can have 100% CPU on your management and 1% on your data plane. And vice versa. Your data plane can be maxed out and your management plane may be very low. Maybe there's some sort of network traffic that is going on that's causing that CPU to spike out. So that's a very good thing to have. This also shows where the data planes was actually doing the network processing, so your NAT, PAT, your routing updates, security processing, so your wildfire, your antivirus, anti-spyware type stuff, and then the signature matching, so matching on hashes, matching on applications, all that good stuff. And here it kind of shows your control plane. So yeah, you do have a management interface and a console interface that's dedicated to that plane. So you can use a management. You can use management on a normal data plane interface. You can use, your normal, say, inside interface to SSH or HTTPS or whatever management method you want to log into your device. So you can do that on the data plane. You can do it on the control plane. But really, this is just trying to get you thinking about what are the differences between the two planes. So again, this is where you're matching signatures, processing, security policies, doing your routing, your NAT, your QoS, all that fun stuff. And that's the first part. I will upload the second part next.